Chapter 10 is a chapter on geometric relationships, and in this chapter we'll study line relations as in Lesson 1, triangles, quadrilaterals, polygons, similar and congruent figures, and then we'll close with sine and cosine relations, special relations in right triangles. And it's really sort of an introduction to a geometry class. It's a big overview of geometry. When we talk about building blocks in geometry, the basic thing that we start with is a point. And a point is a specific location in space. That's what you have to get that in your head, in your memory. A point, specific location in space. You put it down like this. Put a dot. That's a point. There's another point. We could label this point A and this point B. And this is how you name them, with a capital letter. That's how you name points. And you put them, you represent them in space on a 2D shape space with a dot. So points all over the place. And just remember, it's a specific location in space. And we're going to use that to construct all kinds of other things in geometry. The next concept is that of a line, and you'll notice that as we move from one definition to another, we typically will use vocabulary that we developed in the previous definition. So we're going to use points to define line. A line is a continuous, straight set of points that extends without end in both directions. So if I tried to draw that, I would have a straight set of points, but they're continuous, so there's no space in between. And extends without end in both directions. I obviously can't put that on the screen, so I have to represent it with an arrowhead in both directions. So that's a representation of a line, and I can name a line if I name any 2 points on the line, and I'll call that point A and point B. And then if I want to have a way to notate that, so if there's several lines up on a display somewhere, and I want to indicate to you which one we're talking about, we might have this too. We might have intersecting lines and call this C and D. And if I wanted you to focus on this line, AB, I could say, I'm talking about line AB. I just name point A and point B, and I have to put the symbol that is a mini line, like a miniature line right up here. That's very important, because I know then that I'm not talking about something like this, which is be point A to point B, going from A to B, but stopping at A and B. That's a different definition. So a line is continuous, there's no gaps, it's straight, doesn't bend, it's made of points, but there's no spaces in between them. It goes in both directions, infinitely in both directions, no end in sight. A line segment is part of a line that includes the endpoints and all points in between. And notice that we're using the definition of a line that we had in the previous slide to define the one that we're going to talk about in this slide. So with the line segment, we don't use arrowheads because it doesn't continue in both directions. And if I wanted to designate this line segment, I would name the 2 endpoints. That's important. I'm naming the endpoints, and when I draw the symbol above it, it does not have arrows on it. So we know that that starts and stops. It starts at C and ends at D. That's kind of the meaning of segment. It's a part of something. A ray is part of a line that begins at an end point and extends without end in one direction. So we have a beginning point, and we just go from there forever and ever in one direction. So we have to name that end point, and then name any other point on the ray to designate the ray. So we refer to this as ray EF. And the way that we draw this symbol is very significant. If we started with F and went to E, if we went that way with it, then that would be a different ray, different set of points. That would go like this, in that direction. That would be ray FE. And we would write it that way, even though it's not alphabetical order. So the orange is ray EF, and green is ray FE. Parallel lines are lines in the same plane that have no common points, but typically we say they're lines in the same plane that don't intersect. the same plane is a very important idea, and I may need to show that in class to really get a good understanding. Something you have to show, but it's the same flat surface. And I can demonstrate in class lines that never cross each other, but they're not in the same plane, and those are called skew lines. But when I draw it on the screen, it has to be in the same plane because it's the same flat surface. So let's call this line EF. And there's E, there's F, and then we'll do CD over here. And I'm going to, you don't know they're parallel. They look like they're parallel, but if you see that the symbol is what indicates the lines are parallel. These two parallel lines. This is line EF is parallel to. This is red as is parallel to line CD. So the way we read this again is line EF is parallel to line CD. Perpendicular lines are defined as lines that intersect at right angles. Now this is a little tricky because we haven't defined right angles or even angles yet, but I know that you have prior knowledge of what angles are, so I think we're pretty good there. I'm going to take a second to review that. If we have a line here, and we pick a point here, and then we have a ray that goes from this point, this direction, and a ray that goes this way, and the intersection of two rays is defined as an angle. And we have this is a 180 degree angle. If we intersect it and form two congruent angles here and here, they would each be half of 180, so this would be a 90 degree angle, and this would be a 90 degree angle, and that's what right angles are, 90 degree angles. This forms a perpendicular line, lines that intersect at right angles. So the orange line is perpendicular to the white line. And that's what perpendicular means. That's it. A perpendicular bisector is the line that intersects a line segment at a right angle and divides it into two congruent segments. I'm going to show you how you can construct a perpendicular bisector with a compass. Now this is going to be a little tricky since you can't see the compass, so you're going to have to use your imagination. And truthfully, I don't really have a compass. I'm just going to show you kind of how you would hold it and what the markings would be. So we have this blue line. It's a line, it's not a line segment. We're going to pick a point above that line, say right in here, and we put the tip of our compass at that point. The part that doesn't mark, that's what I'm going to call the tip of the compass as compared to the part that has the lead or the pencil. So you put your compass point here, and then you're going to construct from there an arc, part of a circle, that bisects or that crosses the given line at 2 points. So I would have had my compass here, and I would kind of swing it like that. I could go all the way around in a semicircle, there's nothing wrong with that, but I don't need to. Then I'm going to, now I've established this point and this point as the line segment. So I want to construct a bisector that will fall somewhere. It's going to look sort of like this, coming through here, following that path, but it has to find the midpoint of this between A and B. There's a midpoint, right point right in the middle. And you're not using a ruler to find it. You're not going to measure it. You're going to use your compass, and we're going to cross through that midpoint with another line that's perpendicular to AB. So I want to intersect it, and I want it to be at a right angle. So then I'm going to open my compass, and it has to be at a distance that's greater than halfway of the distance between A and B. So if I opened it from here to here, that wouldn't work. I don't want to necessarily be really long with it because, actually I might be in a little trouble here because I don't have much space between here and the bottom of the screen, but we'll try to make it work. So I'm going to put my compass at point A, the tip of my compass, and I'm going to spread it out so it's more than halfway between A and B. And then I'm going to mark an arc above the line and below the line. Then I'm going to go over to point B and put the tip of my compass there and mark an arc above the line and below the line. And these places where it intersects, the arcs intersect here and here, will be connected with the line. This is where you use a straight edge, but you're not using it as a ruler. And when you connect those 2 points, you've found the midpoint, and you've created a 90-degree angle. So if I call this line CD, put CD in there, oops, D, not C, then I could say that CD is a perpendicular bisector. I shouldn't say it that way. I know that it's perpendicular to AB. This doesn't really indicate that it's a bisector. And I forgot to put this in the last slide, that this symbol right here means it's perpendicular to. So line CD is perpendicular to line AB. But this symbol here doesn't guarantee that it is a bisector, but it is because of the way we constructed it. An angle is formed when 2 rays have a common endpoint. So if I have, and this is sort of a representation of an angle, here's the common endpoint. I'm going to call that point B. A point on this line, we'll call it A, and then C. And so I would name this angle as angle A, B, C. So I name a point that is on one of the rays, A, the common endpoint, B, the vertex of the angle, and then a point on the other ray, point C. An angle bisector is a ray that divides an angle into 2 congruent angles. And again, I'm going to show you how you can construct one with an imaginary compass. So here's the given angle. And to construct a bisector, I put the compass tip at this point. And I'm going to draw 2 arcs that extend from there. So that you can actually draw all the way through it if you wanted to, but you really just need this section right here and right here. You have to see where it crosses. Now you know that this would be the same distance. This from here to here would be the same distance as from here to here because you haven't moved your compass. And while my drawing may not be perfect, it isn't. I can tell it's not. But that's okay. Just use your imagination and imagine it is perfect. Then I'm going to put my compass tip here and strike an arc out in this area somewhere. And I'll move my compass tip to here and strike another arc, and they're going to cross over each other. So what that would look like would be from here I'd get an arc that would be sort of like this. Then I move to this point, draw another arc that would look sort of like that. Then I take the compass the straight edge, put it here to here, draw it in there, and that line, our ray, would split this angle into 2 different angles, and they should be congruent. So just imagine if this was originally a 60-degree angle, then this angle would be 30 degrees, and this angle would also be 30 degrees. They would be congruent to each other.